Hey class, here is the study guide for assessment B for the Unit 9 Quadratics test. Alright, the first one says, what is the solution set for this equation? Now, for this video, I will do a few different ways to solve quadratic equations depending on what the equation looks like, okay? So for this one, I'll try solving this by factoring. So I'm going to go ahead and factor out my quadratic here. So since this is looks like a pretty easy factoring because it doesn't have a number in the front here. So I'm looking for two numbers that multiply together that give me negative 18. At the same time, the same two numbers have to add up to negative 3. So let's see, I'll just go ahead and plug negative 18 here and then start looking for some numbers divided by x, and then table, and then here are some factors of negative 18, and then I'm trying to see what two numbers added together give me negative 3. So 3 minus 6, I think that will work. Let's see, 3 times negative 6 gives me negative 18, and then 3 plus negative 6 gives me negative 3, which are my two numbers right here. So those are my numbers. So positive 3 and negative 6. Those are my two numbers that will work. So I'm going to say positive 3, x plus 3, and then x minus 6. Once I found those two numbers, I'll go ahead and keep solving this by setting each of my factors, set it equal to 0. And then x minus 6 equals 0. And then I'm going to add 3 to finish solving. So here's my first solution. So I have x equals positive 3. That's my first solution. So looks like C or D. And then the other one is, I'm going to add 6 on both sides. And then you have x equals positive 6. I did, sorry, this is minus 3, minus 3, minus 3, my bad. So let me do this one over again. So I need to subtract 3 on both sides, okay? So x equals negative 3 is my solution. So negative 3, positive 6, it's A. All right, well that's that, but you know, we can always go ahead and do this in Desmos by just plugging it in and looking at the x-intercepts. So if you have 3x squared and 3x minus 18 not squared, and then if you click on the x-intercepts, they show you what my solutions are, negative 3 and positive 6. That's it. All right. Let me do the same thing for this one. Let me, instead of like trying to factor all this out, let me see if I can find the answers in Desmos. But in order to find the answers in Desmos, I do want to go ahead and set this equal to 0 first, plus 13x. And I'm going to move the 10 over. So I'm going to subtract 10 on both sides. And so that means that I just have to move it over here. Move it over to the other side, so I'll set it equal to 0. All right, let me see what my solutions look like here. All right, let's see. I have one solution which is negative 5, and the other solution is 0.66. The 0.66 must be my fraction. So negative 5 is my solution, so I have negative 5 here, negative 5 here. This is positive 5, so B and C goes away. And then the other one is positive 2/3 right here. Let's see, let me show you. 2 over 3 is 0.66. That's exactly the one, so it's positive. Okay. I do want to take a moment to do this problem using the other method, which is by factoring, since we did spend a lot of time by factoring. So let me show you how to do this also by factoring. If you want to skip ahead to number 3 at this point, you can, but I do want to just show this to you. Okay, so if I'm doing this by factoring, I look for the two numbers that multiply together that give me A times c. So you have to first go ahead and multiply these two. So 3 times negative 10 is negative 30. And then the same numbers have to add up to positive 13. Well, what are the two numbers? I think I can go ahead and use, they have to come out to be negative. Okay, I got it. So positive 15 times negative 2. 15 times negative 2 is negative 30. 15 plus negative 2 is positive 13. Now, instead of just putting the numbers in here like we did in the previous problem, this have a little bit more work. So you have 3x squared. And this is where we're going to use our numbers, our factors. And we're going to rewrite 13 with these numbers. So 15x minus 2x gives me back my 13x, but so I'm just going to use it to rewrite it. This is called factoring by grouping. And then once I write it out like this, we're going to go ahead and group them. We're going to group the first two together, then group the second two together, make sure the negative stays with the 2. And then we're going to factor it out. So the GCF between 3x squared and 15x is 3x. So 3x squared times, so 3x times x gives you my 3x squared, and then 15, so to get 15 that would have to be 5. So 3x times 5 gives me 5x. And here it looks like I can take out a negative 2, so that would be x plus 5. Because like negative 2 times x is negative 2x, and then negative 2 plus 5 is negative 10. If I do all these steps right, I will get the same thing in my parentheses. So that ends up being my first factor. And then my second factor would be 3x and then minus 2. Okay? Once we have this step, we can go ahead and set each factor equal to 0 to find our solution. So x plus 5 equals 0, and then 3x minus 2 equals 0, and then we'll just keep solving. So this is subtract 5 on both sides. So you have x equals negative 5, which Desmos already told us. X equals negative 5. And then the other one is we're going to add 2 on both sides first. So this is 3x plus 2. 3x equals 2. And then we're going to divide that by 3 on both sides. So you have x equals positive 2/3, which is what we have here. Okay? So anyway, those are the two ways. The easiest way is obviously in Desmos. You can just make sure to set it equal to 0 first. Okay? So this part is important. So you'll be able to see the quadratic in here. Okay? Alright, number 3. Which of the following, which shows the correct solutions to this equation? Alright, so for this one, I don't think I have to factor this because it has only one x. I can solve this by taking the square root of both sides. So before I take the square root to get rid of the square, I'll go ahead and just isolate x squared by itself. So I'm going to move the 10 over. So I have 2 over 3 x squared equals positive 10. And then to remove the fraction, I'm going to multiply both sides by the reciprocal. Okay? And then that just takes out everything, all of that. So you just have x squared by itself equals, so 10 times 3/2, I think that's 15, but let's just put it in Desmos. So 10 times 3 over 2 is 15. Because it's 10 divided by 2 is 5, and then 5 times 3 is 15. And then here, we're going to go ahead and take the square root of both sides. So remember, when you take the square root, it will give me that plus or minus, okay? So square root x, not x squared, my bad, just x by itself. X equals plus or minus square root of 15. What that means is you have your positive 15 positive square root of 15 and negative square root of 15. Okay? If you're like, Miss, I just want to do this in decimals, well, okay, let me show you how to do it in decimals. Since my equation is already set to 0, it's already equal to 0, I don't have to move anything over first before I put it in decimals. So 2 over 3 x squared minus 10, there's my quadratic, and then here are my solutions. How do I know that these are the same? Well, let me just see what it looks like. So square root of 15 is it the same? Yep, see, they're the same. Well, square root of 15 and then negative square root of 15 is also the same. Okay, so there are my two solutions. Everything matches up. There you go. Yeah, decimals is really nice. Also, notice I did not put the equal 0, so because if I put the equal 0, it does help me with the answers, but it doesn't really give you the quadratic. I mean, it's up to you. If you want to see the quadratic and find the zeros, you can do like that, or you don't have to put the 0. Okay. All right, number 4. Mina correctly solved 4 quadratic equations using the quadratic formula. All right, the last line of her work for each equation are shown below. Match. We're going to match the statements that best describes the solution or solutions. All right. Well, let's look at each one closely. So, you know that quadratics have 3 types of solutions. We have one where you have just one solution, so maybe it looks like where it touches the x-axis like that. I'm just making numbers up, okay? So I just want to show you what the graphs look like. So here's the first one where there's only one solution. Here's another one where you have no solutions, and then here's another one where you have 2 solutions. So let me move that around. So one solution is where it touches the graph only once. 2 solutions is where it touches the x-axis, I shouldn't say graph, x-axis twice. And then no solution is where the graph never crosses the x-axis. Okay, so that's what these are talking about. And 2 solutions also have these type of solutions, rationals and irrationals. Okay. Anyway, let me go ahead and go through each one and see what works. All right, the first one. This will be no solution. No real solutions for this one. I don't have a graph to graph here, right? But how do I know? Well, because look, whenever I have take the square root of just this part right here, the square root of negative 38, it gives me undefined. Okay, undefined means there's no solutions. You could also do it this way. You can go ahead and put the whole solution in decimals and see what type of solution it has. So square root of negative 38 over 6. It gives me undefined, and that's why I'd say it's no solution. The other one is, oh, by the way, even if you do the plus, I don't have a plus or minus button in decimals, so I have to like manually separate the plus or minus, but still, they both still give me undefined. Okay. The other one is, let's see, I have negative 2 plus square root of 36 over 5, and then I have the same thing except this one is a negative. All right, well, I have 2 solutions here, okay? One is positive, one is negative. And so which one am I going to choose? Am I going to choose the 2 rational solutions or irrational solutions? I will choose rational solutions because these are rational numbers, okay? Rational numbers are any number in decimal form that either terminate, they cut off, or they just repeat, like negative 1.6666 or stuff like that. Okay, so those are rational numbers. And then the irrational numbers, so let me just go down the line. Let me check out this one. So we have negative 2 plus square root of 18 over 5. and then you have this one minus 5. So these are my two solutions, but these are my irrational two solutions. So irrational numbers are numbers that don't just cut off like it did in the previous examples, but they either just keep going and going, and then there's no repeating. They don't have like a pattern of numbers here. Okay, so those are my two irrational. So the last one must be one real solution. Let me go ahead and put it in here. So plus 0, so -2 plus 0 over 5. That's my solution. And then the other one is minus. See how they give me the same answer? Which means, it just means that it only has one solution. Okay, so that's that. All right, next one. Number 5, Mauricio decided to create a rectangular vegetable garden in her backyard. She probably should say his backyard. All right, the length of the garden was 6 feet longer than its width and covered an area of 160 feet. How many feet of fencing does she use? All right, well, so here's the thing. When you have a rectangular garden, so let me go ahead and just draw a picture out. So you have a garden, and what I'm drawing is the fence, okay? So when you're trying to figure out how much this is, that's the perimeter where you're adding up all the sides. But it also needs to meet the area, okay? The area has to be 160 feet. So the space inside the rectangle has to be 160 feet. So there's a couple of things going on. All right, so anyway, the area is equal to the length multiplied by width, and then the perimeter is equal to 2 times your length plus 2 times your width. So here's your length, and then here's your width, okay? 2 times your length plus 2 times your width, so you're adding up all that. So that would be, the perimeter would be just the outside part, right? Only the outside part is the perimeter. Okay, so that's the perimeter, and then the area is the part on the inside. All right, so that's what's going on. I didn't even look at the numbers yet. Okay, so I want the area to be 160 feet. Okay, so that's what my length times my width have to be equal to. And then the fencing, how much fencing, I don't know. I need to know what the perimeter is anyway. So the perimeter will be 2 times your length plus 2 times your width. There's so many unknowns in this so far. So the other part here tells me that the length of the garden, so the length here is equal to 4 feet longer than its width. Sorry, 6 feet longer than the width. So if the width is width, then length is 6 feet longer than the width. All right, so what we're going to do here is we're going to take this, and then we're going to say the length is equal to 6 plus w, this part right here, okay? And then times your width, which is just w. Now I only have one unknown here, which means that I can go ahead and solve this equation now. So this is just a quadratic equation, because look what happens here when I distribute. So 6 times w is 6w, plus w times w is w squared, equals 160. And I know how to solve quadratics. So I can either set this equal to 0, do all of this, or I'm just going to go ahead and put it in Desmos this time, since there's so much going on in this. So subtract 160, subtract 160. Let me write this out nicer. So this is 0 equals, I'll put the square part first, so I'm writing it in standard form, plus 6w minus 160. I'm just going to solve this one by graphing. It's too much to do this. So 6w minus 160. Now, to solve by graphing, I need a graph, right? Well, it's because I put W, it didn't graph. It only graphs if you have X and Y. So I'm just going to change this to X. Still no graph? Well, I just had to zoom out. Okay. Same thing with, let me show you again. It really doesn't graph it if we have W. Look, even if I zoom out, it doesn't have it. But if I change the W's to an X, it will graph it. All right, and then here are my solutions. So I have negative 16 and positive 10. Well, since this is, we cannot have a width length of a negative number, that's just not possible. I'm going to just use the 10, okay? The 10 is what I'm going to use for the width. So the width is 10, which means that the length is 6 plus 10, which means the length is equal to 16. It's not this 16, okay? It's not this 16. This has nothing to do with this 16. This is just that the length is the width plus the length. So that's that, okay? All right, now what? Well, I figured out what the width and length are. Now I can go ahead and finish the problem by saying how many feet of fencing. Fencing is talking about the perimeter. So to find the perimeter, I'm going to do 2 times your length. My length is 16. Plus 2 times your width. My width is 10. There you go. So the perimeter is 2 times 16, which is, I'll just put it all in decimals, 32 plus 2 times yours is 52. So the perimeter is 52. So, trust me, this was supposed to say 52, my bad. 52 feet. I just forgot to type that. I typed the wrong number. Okay. All right. That was fun. It was. All right, next one. It says, what is the solution? All right, you guys. So since I can probably just put this in Desmos and graph it and find the answer, which is actually a really nice way to do it, except it's not going to be that easy. If I look on here, I have these numbers, but then this is a multiple select, so I have to like try very random numbers to get the answer. So this is really one of those problems where you really just have to know how to do the problem, okay? This is not factorable, meaning that I can't find 2 numbers that multiply by 2 that add up to -6. I cannot factor. So since I cannot factor, I'm going to have to use the quadratic formula, okay? Quadratic formula is the only formula that I will give to you on the test, or the only formula that you receive on the SOL. So here's what the quadratic formula looks like. Okay, here it is right here. This is the formula sheet that you'll get. Okay, let me go ahead and copy it down. I really don't have to copy it because my Algebra 1 teacher back in the day made me memorize it, but let me go ahead and write it over here. So you have, oops, x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay? All right, so I'm going to go ahead and plug in my numbers. So you have x equals -b. So b is -6. Make sure to take the value of it, so that's -6 plus or minus the square root of b squared, which is -6 squared, minus 4 times a. A is the number here. There's no number there, so which means a is 1, times c, and then c is 2, all over 2 times a. A is also 1 again. All right, so when we're solving the quadratic formula, we like to simplify first. So -6 times -6 will be +6, plus or minus the square root of all of this. I'm going to put this part in Desmos. So I'm going to do -6 squared minus 4 times a times c which is 28 down here. And then 2 times 1 is 2. I don't see any of these numbers on here. Well, there's only 2 parts here, so that means I have to probably simplify this more. All right, to simplify, I need to go ahead and simplify the square root of 28. So the square root of 28, let me go ahead and do it over here. So the square root of 28 can be written as, let's see, square root of 4 times square root of 7, because 4 times 7 is 28. So square root of 4 is 2, so that's 2 square root of 7. Okay, look, square root of 28 is the same thing as 2 square root of 7. See, they're equivalent. So let me go ahead and write this out. So that means I have x equals 6 plus or minus 2 square root of 7 over 2. Now we're getting somewhere, but looks like I only have 2 boxes and I have all these numbers. Well, what happens here is the 6 gets divided by 2 and then 2 gets divided by 2. So this actually ends up being 6 divided by 2 is 3 plus or minus 2 divided by 2 is just 1, and then so that's gone, so you just have square root of 7 left. So that means that here is 3 plus or minus square root of 7. So basically, like, you're going to drag these in there. Okay? All right. Number 7. This looks weird. It says match the correct number of solutions of quadratic equations represented by... Okay, oh, this one is easy. So this one is just one solution because it's touching the x-axis only one time. So that means this graph goes to here, one solution. This one has 2 solutions right there. And this one has no solution. This is not a solution. It says y-axis. Solutions are only on the x-axis. So this one is, this graph is no solution. Okay? All right. All right. Mora solves the equation x minus 2, x plus 3 equals negative 4. She uses graphing technology, so basically she uses Desmos to help her. Below are the functions and graphs that form her graphing technology. I don't know what that sentence is trying to say. Anyway, this is what she did. So she graphed these 2 things in Desmos, and this is what she gave. What are the solutions? Well, the solutions are going to be where your function is equal to negative 4. So here's negative 4. So where equals to negative 4 is where it touches this graph right here. So this one, this is a solution. And what am I doing? Negative 2 is a solution, and then this is also a solution. 1 is a solution. So negative 2 and positive 1. Okay? In this case, it does not mean negative 3 and 2 because I have the graph. It's just that because we added the negative 4 over here, that's what makes it look at different things for the solution. Okay? Let's see if I can just graph it and find the answers as well. I think I can. And then I'm going to move it. Well, let me see if this works. I think this also works. Negative 2 and positive 1. Yeah, that also works. All right. Which graph has a solution set of negative 4 and 0? Okay. Negative 4 and 0. It's A. This one is negative 4 and positive 2. This one is negative 2 and positive 4. This one is 0 and positive 4. So anyway, it's A. Alright. I think that's the last one. Let's see. Yep, that's the last one. Alright. Thanks for watching, guys.